Welcome to Physics 310. We are going to start Chapter 2. Chapter 2 is about kinematics in one dimension. What is kinematics? And it is defined as branch of mechanics that studies the motion of a body without regard to the cause of that motion. Okay. Here we are talking everything about motion, except we are not talking why things are moving. In other words, we are not talking what makes things to move, what force is responsible for making things to move. These things we are not studying in this chapter. We will simply study different parameters of motion, such as distance, displacement, average velocity, average speed, average acceleration, instantaneous velocity, and instantaneous acceleration. So these are the things we are going to talk in this chapter. If things are moving in a straight line, suppose you roll a ball and it moves in a straight line on ground. This is motion in one dimension, right? In one direction, you can say that. On the other hand, if you throw something, it goes up in a straight line and comes back in a straight line. Okay, and comes back in a straight line. So this type of motion that occurs in horizontal plane or in vertical plane, these types of motions are known as motion in one dimension. In other words, here only the x coordinate is changing, here is only the y coordinate is changing. Okay, so motion that happens purely in x coordinate and motion that happens purely in y coordinates is known as motion in one dimension. You can make it x like this and y like this, horizontal as x and vertical as y. So now let's talk about distance. It's the actual path length. If something is moving, its actual path length is known as distance. Okay. And what is displacement? It is defined as final position minus initial position. I am going to explain the difference between the two with few examples. If someone is walking, okay, suppose someone is walking, he goes 10 meters this way, how much distance he has traveled? 10 meters. Okay, actual path length is 10 meters. How much displacement he has? He has also, the initial position is this and the final position is this, so the displacement is final position minus initial position is 10 meters. Alright, now see what happens. If someone comes here and then someone walks back 10 meters, so he is coming this way 10 meters in plus x direction and going back 10 meters in minus x direction, going back this way. Now how much is the total distance? In this situation, your initial point is this, okay, and your final point is the same place. So the total distance is the actual path length. Going 10 meters this way, coming back 10 meters this way is 20 meters. And what is displacement? Your initial position is this, your final position is the same place, so your displacement is 0. Alright. Let's see another example. Suppose I draw the directions east, west, north and south like that. If someone drives 100 miles towards east, suppose someone is driving a car and he goes 100 miles towards east, and then another 100 miles towards north. Okay, total distance in this situation is 100 plus 100 is 200 miles. And what is the displacement? This is your initial point. Suppose this is A, he goes to B and then C, then final position minus initial position. So connect the final position from initial position by a straight line. Suppose this is a straight line and this straight line, it is pointing towards final position from initial position like this way. This is going to be displacement. This is displacement. And how much this is going to be? This is going to be, you know, if this is a right angle triangle, you can easily find out how much this is going to be. It is going to be square root of 100 square plus 100 square miles. So displacement is square root of 100 square plus 100 square miles. This is, if you calculate it, it comes 100 square root of 2, and you can find this number 100 times approximately 1.41, and you can multiply this is 141 miles approximately. Okay, because this is approximate number. Alright. So now you understand what is the difference between distance and displacement. Alright. Distance is actual path length and displacement is final position minus initial position. And SI unit for both distance and displacement is meter. Alright. Now let's talk about average velocity. What is average velocity? It is displacement divided by time. Displacement over time. Time involved in this displacement. Alright. Let's take an example. Suppose I plot position and time together. So position, I can say x is on this axis and time t is on this axis. Okay. Suppose someone is moving forward with time. Okay. Then going back, then going again forward. Here is the starting point A, here is the end point B. Okay. So what is displacement? Okay. Displacement is final position minus initial position. This is the final position, x final. What is initial position? X initial. And t final, this is t initial. So displacement is x final minus x initial over t final minus t initial. You can also write this delta x over delta t. So you have to see only the final position, you have to see only the initial position, take the difference, that will give you displacement. It doesn't matter how in between he is going, but you have to consider only final and initial positions. And then at what time he is at the final position, at what time he is at the initial position. So you get delta x. This is your delta x and this is your delta y. Delta x over delta t will give you V average. So V average is delta x over delta t. That's the average velocity. How about average speed? How do you get this one? Now you have to find actually how much he travels. Okay, look at this one. From here to here, from this point to this point, he is moving forward. Okay, this much length. This is average speed, is total distance traveled over time, or time involved, over time involved in that travel. Okay, in that time involved in this travel, total time, time elapsed. So what happens here? How to find total distance? Suppose in this path from here to here he is moving forward. Okay, how much forward moves? This much. So you measure this distance, okay, in forward direction. Alright, then from here to here what happens? He is moving backward. Measure this distance, how much backward? Okay, this is the backward distance, this point to this point. This distance is the backward distance. And from here again moves forward. Okay, so this is this is how much he moves forward. This is from this point to this point is the forward, this point to this point is the backward, from this point to this point is forward. So add forward, backward, forward, all these distances together, and this will give you total distance over. Now time is this, again, total time in between, how much time it takes, that is t final minus t initial. Okay, the SI unit for velocity and speed are same. Average velocity has SI unit, that is SI unit is meter per second. Here also the SI unit is meter per second. Okay, now next thing is the acceleration. Average acceleration. Average acceleration. What is that? This is average is change in velocity over time involved. Time involved in this change over time. What time means? Time involved in this change. So delta V is the change in velocity over delta T is the change in time. So what would be the SI unit of average acceleration? AVG for average. AVG means average. Delta V over delta T is meter per second, is delta V over second. Okay, and this, if you simplify this you can write as second over 1. So meter over second times 1 over second, that gives you meter per second square. You know that A over B divided by C over D, this is equal to A by B times, and when you multiply this you flip this, D over C. Okay, this is equal to this. Now the next thing I'm going to discuss is instantaneous velocity. You can get velocity by position and time graph. Like if you have position and time graph like this axis is for time and this is for position, X or Y, anything you like. You can put over there. If something is moving with a constant velocity, what does it mean? It means that its position and time graph will be a straight line. Okay? If you have a straight line means a time t is equal to 0. This is the position, alright? And as time goes up and up, there is a constant change in delta x. Okay, this is your here this is, if you take an interval of time, this is delta t and this is delta x, and if you find the slope, you get v. V is delta x over delta t. Alright, if you take another 2 points right here, and if you find, if time interval is same, if this time interval is same, this delta x is also going to be same. Alright, so no matter where you choose the point, if you keep same time interval, you will have same delta x. Okay, and ratio will be same. Alright, so no matter where you choose 2 points, this ratio is going to be same. If it is a straight line, you can say the velocity is constant. Alright, means velocity here, 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 any place you take, the velocity will be same. Okay, now let's take another example where this graph is not a straight line. Suppose this is time, this is position, and if your graph is something like this, what does it mean? It means that if you suppose you have a time 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds, 7 seconds, in 1 to 2 seconds, change in position is only this much. Okay, this is your delta x. This is x1, position at 1 second. This is x2, position is 2 seconds. Now let's see here what happens. Suppose I take the position at 8 seconds. This is x8, position at 8 seconds, and this is position at 9 seconds, x9. Now look at here. Here if there is time difference of 1 second, delta x is small. Okay, delta x over delta t will be giving the velocity from 1 to 2 seconds, delta x over delta t. here delta x for same time interval is large. So here delta x over delta t is going to be large. The velocity will be more. Okay. How about between 3 seconds and 4 seconds? Suppose this is like this. Between 3 and 4 seconds the position is going to be same, almost same. This position is on. So velocity is delta x is 0. Okay, suppose this is completely a straight line. This delta x is 0 and delta t is 1 second, so the velocity is 0. So here the velocity is less, here the velocity is 0. What happens here? So between 4 and 5 seconds delta x is negative, so the velocity is negative, because delta x, this is x initial, this is your x final. So delta x is negative from here to here. This is final position, this is initial position for this interval. Final minus initial, final is less, initial is more, so final minus initial will be negative. So delta x is negative. So delta x over delta t. Delta t is always positive. Time is always positive. Alright. So delta x over delta t will be negative. Here the velocity is negative. Okay. So if you see this graph, it is always the velocity is changing. Alright. Sometimes slow velocity, zero velocity, negative velocity, and it is increasing here. If you see that, positive velocity is increasing. Alright, this is not a straight line graph. If it is a straight line graph, the velocity is always constant. So here what we can do, we can find the instantaneous velocity. Instantaneous means I choose an instant. Suppose I want to know what is the velocity at this point A. Okay, and this position is, suppose this is, I say this is x A and this is t A. Okay, what is velocity at point A? Means at this instant ta, what's the velocity is. How can we do this? Because velocity is delta, change in position over change in time. So what I will do, I will take a tiny change in position. Okay, let's say this is very tiny change in position, and there is very tiny change in time. I take a very tiny difference here. So V instant is going to be x position at time something t plus delta t. Delta t is small time interval minus position at xt at t instant. Okay, I have put a here. You can simply say it is t here because it looks more convenient to write x and t. So this position is xt plus delta t, means you move little bit more, very tiny amount of time, minus position at t over delta t. and you shrink this interval, so limit delta t tends to 0. Means you shrink this interval so narrow that it becomes a point. Alright, so delta t tends to 0. This is called instantaneous velocity. In calculus, this is written as dx over dt. Instantaneous acceleration. What is instantaneous acceleration? You have velocity on this axis and time on this axis, and you have graph something like that, velocity versus time. I want to find velocity at this instant, so I take a tiny interval of delta v and tiny interval of delta t. This is delta t, this is delta v. Okay, so a instant is equal to v t plus delta t minus v t over delta t, and this delta t you shrink so much that it comes to this point. Limit delta t tends to 0. That becomes dv over dt. And you can also write this as d over dt. V is dx over dt. So this becomes d2x over dt2. Right? So this is instantaneous velocity and instantaneous acceleration. Now I want you to learn the 3 kinematic equations. Alright, they are very important and they will be used throughout this chapter, and also they will be used in chapters that are coming. Alright, suppose something is moving. Alright, maybe a car. Here is the starting point. Its position, you can say x initial, x0, x0. That's the initial position. And here its velocity is v0 or v0. That's the initial velocity. So x0 is initial, x0 is initial, x0 is initial position, v sub 0 is initial velocity. Now it is accelerating. A is constant acceleration. Okay, so when you accelerate your car, what happens? The speed goes up and up and up and up. Right? So suppose it comes here, and this position is x, and here the velocity that we call final velocity is v. So x is final position and v is final velocity. Initial time, here it is 0, and here the time I can give a symbol t. This is final time. Alright, this is initial time. So initial time is 0, final time is t. Okay, so there are three kinematic equations of motion. These three equations are: final velocity is equal to initial velocity plus a times t. Okay, final velocity is equal to initial velocity plus acceleration time times t. T is the time. Final velocity square is equal to initial velocity square plus 2a times delta x. Okay, delta x means, what is delta x? This is delta x. Delta x means final x minus initial x. And the third equation is delta x is equal to v initial t plus 1/2 at square. Alright. Okay, there are the three equations. If something is moving in horizontal plane in a straight line with a constant acceleration, remember, if acceleration is constant, then only these three equations are valid. Okay, while things are accelerating. Okay, it is also valid while things are decelerating. Decelerating means negative acceleration. A is either positive or it is negative. When it is positive, it is acceleration. When it is negative, it is deceleration. Okay, so in both cases, these three equations are valid as long as A is constant. Alright, either positive or negative. Many times, for the clarity, if something is moving along x direction, we add the extra suffix here. Okay, v final x is equal to v initial x plus at. v final x square is equal to v initial x square plus 2a delta x. Delta x is equal to v initial x t plus 1/2 at square. Alright, putting suffix here means that it is happening on ground, on horizontal. Okay, on x-axis. Okay, your x-axis, this can be taken as horizontal, and your y-axis can be taken as vertical. So putting extra suffix adds the clarity. Alright.